So in this video, we're going to learn about Pascal's law. So Pascal's law is very important in this chapter. So let's see what it says. It says that if a pressure is applied on a liquid or a gaseous enclosed in a container from outside, then this pressure is transmitted equally and acts perpendicularly on the surface of the container in contact with liquid atoms. Okay, so let me break this in now. This is suppose you have this sort of piston. This is called piston. Okay, it has a certain surface area, and on this side it also has a certain surface area. Okay. All right. So now, if you and suppose in this piston there are some water within it. Suppose some water within it. Okay. Now, if you apply some force on this side of the piston, a certain amount of force will exert on this side. If you exert this force on this direction, a certain amount of force will be working on this direction due to the application of force. Okay. So Pascal's law said that when we're talking about pressure, not the force, right? We're talking about pressure. So if the pressure applied on this liquid and gaseous enclosed container, this is an enclosed container where there is liquid and a certain kind of pressure is exerted on this side. Okay, so it says that then this pressure is actually transmitted equally. This pressure, although the area of this piston is bigger, the pressure is transmitted equally and acts perpendicularly on the surface of the container. So on the surface of the container, the pressure will act perpendicularly on this surface of the piston, okay, which is in contact of the liquid or gas. So this is application of Pascal's law. Suppose you apply some force. So if you apply some force on an area, of course there will be pressure. Of course that will give you some pressure. Okay, so let's stick to the force. When you're applying force on this part, so don't confuse it. I'm saying this thing again. When there is pressure, there is force. There has to be a force. Okay, so when you're applying a pressure on a unit surface area, that means there is a pressure within it. Okay, so when you're applying force within this surface area, a pressure is automatically working on this side. And due to the force that you have applied on this side of the container, there also acts a force. Now, Pascal's law says that we know that force is equal to what? We know force is equal to what? From the chapter of pressure, we know that force is equal to, we can write. Okay, before force, let me just say this. So we know that P is equal to F by A. So what is equal to F is equal to what? F is equal to A P. F is equal to A P. Okay. So the force which you're applying on this side, suppose this is F1. So for this is F1, and the area, surface area, is also on this side is A1. Suppose this is A1, the surface area of this. Okay, this is A1. So the force acting on this side of the container is A1P. A1P. Okay. Now the force acting on this side of the container is F2. So what is the force? What is the force on this side of the container? F2 is equal to A to P, right? Now this force is because F2 is because of the force which we applied on this side, F1. This is because of the force that you have applied on this side. Now F2 is equal to, you can write that F2 is equal to, we know that A to P. So what else can we write? So from these, what else can we write? We know that P is equal to F1 by A1. P is equal to F1 by A1. Let me write it over here. We can also write from this formula that P is equal to F1 by A1. Now F2 is equal to A to P. Okay, so let's write this down. A2, sorry, A2, and instead of P, I'm writing F1 by A1. F1 by A1. So I can write this, right? So now my F2 is equal to, A2 by A1 into F1. So this is an important formula. This is the formula that we'll be using for all piston sort of problems. That the force acting on this side is equal to the ratio of A1 and A2 times, is equal to the time, is equal to the times of ratio A2 by A1. Suppose, let me give this example. Suppose this is, the area of this side is 100 meters square. The area of this side is 1 meter square. Now, according to this formula, what will be the force acting on this side? So let me show you. F2 is equal to, we know A2 by A1, which is 100 by 1 into F1. So F2 is equal to 100 F1. So that means the force will be acting on this side will be 100 times more than the force acting on this side. So that means, suppose if you are giving 1 Newton force on this side, the force that we will be getting from here is 100 Newton. So that's how basically you convert a force of less into a bigger force, or as there is area in there. So what is the reason that we are applying force? In order to get pressure, right? Pressure is our aim to get. So we are applying this force so that there exerts a certain amount of pressure, and when it comes on from this side, the pressure becomes higher. So applying less pressure, you are getting more pressure on this side. So this is a conversion of pressure. Through this container, you are getting more pressure. Okay, so this is the idea of Pascal, that if you want to increase the pressure of any substance without using using much energy, you can do that easily. You can easily give 1 Newton of force, and within this side, and from this side you will get 100 Newton of force. Okay, so this is the idea of Pascal.